Welcome everyone. In this video, I am going to talk about triple integral. I'll be talking about change of variable in triple integral, especially change in variable, that how to change a rectangular coordinate system into cylindrical coordinate system, and how to change a rectangular coordinate system into a spherical polar coordinate system. This video will be slightly longer because we are going to discuss multiple kind of problems. So please watch till the very end so that you don't miss any concept. In case if you are new to the channel, you should subscribe it because here you get good quality video content. So let's start. So first of all, I will do some problems which will be directly related to evaluation of triple integral. And as we have seen earlier, in case of double integral, we should not be intimidated by the expression, because basically in triple integral we have to integrate it 3 times. Like in case of double integral, we were integrating it twice. But only thing that we need to be careful about, that what is the order in which we are going to integrate them. So here if you look at this, it is written dx, dy and dz. So if you just go by the way it has been written, it looks like that first we have to integrate it with respect to x, and then with respect to y, and then with respect to z. But that will not be correct, because the primary focus should be on the limit that is given there. So if you look at the limit here, it is given to be x minus z to x plus z, and the limits are given in terms of x and z. So certainly it should be the limit of y. So even though it is written dx, dy and dz, first we will integrate it with respect to y, and once we will integrate it with respect to y, the next thing is 0 to z, means that will be the limit of x, and finally this is the limit of z. So let us do the computation quickly. Nothing is special about this, we just need to be focused in the way we are going to calculate it. So I'm not going to copy this problem directly, I'm just going to start the solution. So this is equal to, so we have the limit of integration minus 1 to 1 and then 0 to z, and first we have to integrate it with respect to y. So x, and x is a constant, so xy plus y square by 2 and plus zy, and the limit of integration is x minus z to x plus z, and then we have dx and dz. So let's substitute the limit minus 1 to 1, 0 to z. If we put the limits of y, so x plus z minus x minus z. So what will be that? Let me write it. X plus z minus x, and minus minus will become plus, so x plus z. Then I will have half, and here I will have y square, so that is x plus z whole square, and minus x minus z whole square. Okay, and then plus, let me write it over here, z, and again x plus z, and minus x, and then plus z. Okay, close the bracket, write dx dz. So this will be what? This will be minus 1 to 1, 0 to z, and you can see this x and x cancel, so I will get 2z into x, so I will get 2zx, and here x plus z square minus x plus z square, so 4xz. So I will again get, I hope you are clear about this expression that we have studied in our high school, a plus b square minus a minus b whole square, so that is equal to 4ab. Okay, so it will be like 4xz by 2, that is 2xz, and what will be this minus x and x cancel, so z plus z is 2z into z, so that will be 2z square, and then dx and dz. So next is minus 1 to 1, so 2zx and 2xz, 4xz, we have to integrate it with respect to x. So if we integrate 4zx with respect to x, so 4z will be constant, integration of x will be like x square by 2, and plus 2z square, so 2z square will be a constant, integration of dx will be just x, limit of integration will be 0 to z, and then dz. So if we cancel here, I will get 2, so 2zx square and 2z z square x, but let me put the limit first. So I will get minus 1 to 1, and if I put the limit of z here, not sorry, I have to put the limit of x, so it is 2z into z square, so I will get 2z cube, and here also 2z square into z, so I will get 2z cube, and if I put the lower limit 0, so 0 square will become 0, so this term will become 0, this term will become 0, so 0 minus 0 is 0, so that is we get dz. Now finally we have minus 1 to 1, and we have 4z cube dz. So it is an odd function. In case if you are not going to think like this, you just integrate. So z cube will give you z to the power 4 by 4. Limit of integration will be minus 1 to 1. So if you put 1 here, and you can take 4 out, so 1 to the power 4 is 1, and minus 1 to the power 4 is minus 1, so that is equal to 0. So what we get is equal to 0. You could have directly written also that this is equal to 0, because 4z cube is an odd function, and I hope you remember this result, that if I integrate something from minus a to a, and that function is an odd function, then the integration is equal to 0. So as you have noted, there is nothing special about this. We are just integrating it 3 times, and only thing that we need to keep in mind that while we are integrating it, we are keeping the order and looking at the order in a very careful way. So I think this problem also we can do very quickly. And to solve this problem, I think I would suggest you to pause the video and do it yourself, and then see that whether you are able to do it or not. So this is very much clear that it is the limit of 0 to 1 under root 1 minus x square minus y square. So this will be the limit of z, then it will be the limit of y, and this will be the limit of x. So even though it is written dx dy dz, we will integrate it in the order of z with respect to z first, because this is the limit of z, and then with respect to y, and then finally with respect to x. So I'm going to write directly the solution. I'm not going to copy the problem. So 0 to 1, 0 to under root 1 minus x square, and first we have to integrate it with respect to z. So xy will be a constant. Integration of z will be z square by 2. Limit is 0 to under root 1 minus x square minus y square, and then with respect to z we have done, so dx dy. Then this is equal to limit is 0 to 1, 0 to under root 1 minus x square, and then xy by 2. And if we write z square, the square root will be gone, so I will just get 1 minus x square minus y square. And if I put z is equal to 0, this expression will become 0, so I will get dx dy. Now we have to integrate it with respect to y. So 0 to 1, and x by 2 is a constant, right? So I write x by 2. With respect to y, so you see I'm going to multiply y in these 3 terms. So first 1 into y will be y, and if I integrate y with respect to y, I will get y square by 2. Then we have minus x square y, so I will write minus x square into y square by 2. And then we have minus y into y square y cube, so I will get y to the power 4 by 4, and limit of integration is 0 to under root 1 minus x square dx. Now this is equal to what? This is equal to 0 to 1 x by 2, 1 by 2 y square, so I will write 1 minus x square, minus x square by 2, and y square again is 1 minus x square, and minus 1 by 4, and y to the power 4 means y square square, so this will be 1 minus x square square, and then I have to integrate this with respect to x. Now I would suggest you that you have to integrate it with respect to x and tell me what is the answer. Take a pause, right? Because everything is now in terms of x. You just have to simplify this expression and integrate it with respect to x, and finally put the limit of x from 0 to 1. Tell me what is the answer that you are going to get. I am not writing the answer, so I am writing answer in comment. Answer in comment. just to make sure that you at least are able to do the computation and also kind of know how to substitute the limit. Okay, so I think you have completed the computation. So now let us quickly solve this problem, and then we will move to another kind of problem. So if you look at this particular problem, here the limits are 0 to a, 0 to b, and 0 to c. So it is not clear from the limit that whether it is the limit of x, y, or z. So in this case, what we are going to do, we are going to evaluate this integral first, means with respect to x first. Then I will integrate this integral, means with respect to y, and then finally with respect to z, right? So what I am going to do, I am going to write the solution. So just without copying the question, I am starting it 0 to a, 0 to b, and first we have to integrate it with respect to x. So we have x squared, so that will give me x cube by 3. Then we have y squared, so y square x, and then we have z square, so z square x, and the limit of integration is 0 to c, and then I write dy and dz. Okay, so if I put the limits, what will I get? I will get 0 to a, 0 to b, and the limit of x is 0 to c, so I will get c cube by 3 plus y square into c plus z square into c, and then dy and dz. Next we are going to integrate it with respect to y. So limit is 0 to a with respect to y. So first it's c cube by 3, so c cube by 3, as such integration of dy is y. Then c and y square will give me y cube by 3, and plus z square c and then y, and the limit is 0 to b, and then we have dz here. So if I put the limits, I will get 0 to a and c cube, so I will write c cube b by 3, then c b cube by 3, and I will get z square c, and in place of y we have to put b. And if I put 0, that is lower limit, so minus 0, minus 0, minus 0, because y, and y. So if you put y is equal to 0, every term will become 0. So this is dz. So let me finally integrate it with respect to z. So I will get c cube b by 3, integration will be z, plus c b cube by 3, and integration of dz again will be z. And here we have bc, cb I have written bc, z square will give me z cube by 3, and integration will be 0 to a. So if I put the limit a here, I will get a b c cube by 3, the first term. The second term, z is equal to a, so I can write a b cube c by 3. So I can write a b cube c by 3. And finally the third term, so z is equal to a, so I will get a cube bc by 3. And if I put 0 here, this term, and this term becomes 0. So this is the answer, but just to make it look better, I can take abc by 3 common, and I will get what? From this I will get a square, from this I will get b square, from this I will get c square. So a square plus b square plus c square. So it looks very symmetrical, and I hope you have understood the computation part. Okay, so we have done 3 problems. We are already around 13 minutes into the video. Now let us quickly solve this problem. So using triple integral, we can find the volume. So how to calculate the volume, that we also have seen in one of our previous video, but there I was using the double integral. But we can also use triple integral to calculate the volume, right? And in case of triple integral, if you want to calculate the volume, you have to solve it like this. So I am going to explain this through through solving this problem. So basically if you integrate something, and this is the concept, sometimes people ask this also, that if we integrate the volume element like dx dy dz over the region V, then what we get is we get a volume of V. Okay, so what does this region means? Can we draw the region? So if you draw x-axis like this, suppose let me call it this as z-axis and this as y-axis. So this is the plane, that is x plus y plus z is equal to a. So this is a standard form of the plane. Basically it is x by a plus y by a plus z by a is equal to 1. So it will make an intercept of length a on x, length a on y, and length a on z. So if I join this, this is how the region will look like. Let me redraw this line because it does not look good, and again redraw this line. So let me join it like this. Okay, now join it like this and join it like this. Okay, let me call this as origin O. Let me call this point A, this point B, and this point C. So basically what happens, if you want to use the triple integral, you have to integrate dx, dy, dz. So what I'm going to do, I'm going to take a solid element. I don't know whether you can visualize this, but there is a solid kind of element that we are going to take, and this is a structure. So if you see, if you take a solid structure, something like a rod structure, so if you look at this, it is going to start at z is equal to 0, because this is xy plane whose coordinate, or whose equation is z is equal to 0, right? And it is going to go up to this plane, that is ABC. So what is the equation of this plane? The equation of this plane is x plus y plus z is equal to a. So if I write z, it can be written as a minus x minus y. So we have got the limit of z. I can write the limit of z from 0 to a minus x minus y. And since I have written the limit of z first, I am going to write dz. Now how do I take the limit of x and y? So to take the limit of x and y, what I am going to do, I am going to redraw this region which I have OAB. So I am going to redraw the cross section of it. Suppose I call this x-axis, and now I am calling this as y-axis. So OAB region looks like what? This is the point A and this is the point B. So we have to move this in to cover the entire OAB region. And what is this OAB region? This is the projection of the plane, that is ABC plane, in the XY plane. I hope you understand it. I am taking the plane that is x plus y plus z is equal to A, and if I take its projection in XY plane, the projection will be the region OAB. So I have to cover the region OAB. I already have taken the limit of z. To cover the region OAB, I take a vertical strip which starts at a x-axis, so its limit will be y is equal to 0. And now if I look at this line, its equation will be x plus y is equal to a, right? Because z is 0. So now in 2 dimension, if I look at the projection of this plane in xy plane, it is the line AB whose equation will be x plus y is equal to a. So the limit of y will be varying from 0 to y is equal to a minus x. Okay, and then you have to move it from 0 to the point A. So this point is limit is 0 to a small a. Okay, so next thing is that we have to evaluate it, and I have taken the limit of z first. So I wrote dz, then y, then I write dy, and then finally x, so I write dx. Now I have to do the computation. So the computation part is very easy. We can easily calculate. So 0 to a, then 0 to a minus x. The limit of dz is z, so I will write z, and limit is 0 to a minus x minus y, and then dy dx. So this will give me what? This will give me 0 to a, this will give me 0 to a minus x, and z will be a minus x minus y. If I put z is equal to 0, I will get 0, I will get dy and then dx. Then this is equal to 0 to a. Now we have to integrate it with respect to y. So I will get ay minus xy minus y square by 2. Limit is 0 to a minus x dx. So continuing here, because we don't have a space, so that we can manage. So I will get what? I will get 0 to a, and a into a minus x minus x into a minus x minus half and a square, that is a minus x whole square. And if I put y is equal to 0, this term, and this term, everything will become 0. So I will just get dx. Now what I would suggest you, that you need to integrate it with respect to x and let me know what is the answer. Okay, so would you like to integrate it with respect to x, or should I evaluate it? So let me evaluate it, because you will think that I'm leaving a lot of problems for you. So 0 to a. See, if you have this thing, you have a minus x. So if you take a minus x common, you will get a minus x into a minus x. Let me write it one more time. So I will get a minus x square and minus half a minus x square dx. So we can further simplify. A minus x square minus half a minus x square is 0 to a, and it will be half a minus x square dx. Okay. Now if we have half a minus x square dx, we can integrate it. 1 by 2 is a constant. Integration of a minus x square will be a minus x cube by 3, and since the coefficient of x is minus 1, I will write minus 1 here, and the limit is 0 to a. We don't have a space, so just I don't want to move to the next page. I want to compute here. So I have to put the limit this. I hope you have understood the integration. We have a minus x whole square. So the integration will be a minus x cube by 3. But why I am writing this minus 1? Because the coefficient of x is minus 1. So now we have 1 by 2, 3 into minus 1, that is minus 1 by 6. So I write it over here. We get minus 1 by 6. And if we put the upper limit, that is a in place of x, we get a minus a, that is 0 cube. So that I will get 0 and minus. If I put 0 here, I will get minus a cube. So what we get? We get minus 1 by 6 minus a cube. So what we get is a cube by 6. Right. So this is the answer. Since we are calculating the volume, we can write cubic units if you want, but there is no such compulsion. So that is the answer. That is a cube by 6. You can remember this also, because sometimes they ask this question as a multiple choice question. And what they do, they just write the plane like x plus y plus z is equal to 6, or x plus y plus z is equal to 12. So if you remember this, that x0, y0, z0, and this gives you the answer a cube by 3. So you can directly substitute a value and get the answer. I mean, MCQ strategy. Anyway, moving forward, suppose we have to find the volume of this ellipsoid. Ellipsoid is a structure. I don't know whether you can visualize. Suppose you consider an ellipse and you rotate it. Suppose you rotate it about x-axis, so you will generate a surface. That surface that will be generated is known as ellipsoid. So if I have to ask you that how to find the volume of the ellipsoid, so can you just pause the video and try to write it yourself? So I hope you have thought about this. First of all, if I have to find the volume of the ellipsoid, in the picture, if you look at this, I have taken the portion of the ellipsoid which is in the first octant. I hope you understand the term octant, right? Because in 2 dimension you divide the plane into 4 parts, that is 4 quadrant. But in 3 dimension there will be 8 octant. 4 of them will lie above z is equal to 0, and 4 of them will lie below z is equal to 0. So if you look at this plane is basically z is equal to 0, xy plane. So it is the volume in one of the octant. And I hope that you are also clear that actually it will be symmetrical. So in all the 8 octant, the volume will be the same. So if I have to calculate the volume of the ellipsoid, what we can do, we can calculate the volume in one of the octant, and then we can multiply that by 8. Okay. So how will you evaluate it? So I'm going to write it. Limits we have to decide. So let me write the limits. So first of all, we have to take the limit of z. If I take a solid structure like this, so it will start at z is equal to 0. And if you look at this equation, it is x square by a square plus, I think there is a problem here, because the problem is that when we talk about ellipsoid, actually this a, b and c should be different. So basically if you consider this as ellipsoid, it will become a circle, right? So just a small correction. I take it x square by a square, y square by b square, and z square by c square. Right, so this is the ellipsoid. Otherwise, if you take a square, a square, a square, then it will become a sphere, that is x square plus y square plus z square is equal to a square. I think I used the word circle, which is not correct. It will become a sphere. But we are talking about ellipsoid, so I am taking a, b, and c, which are all different. So then I realized that I have made a mistake in typing it. So x square by a square plus y square by b square plus z square by c square is equal to 1. So I have to write the limit of z. So it will start in xy plane and it will go up to the surface of the ellipsoid. So if you solve it, what will be the z? Z can be considered at z square is equal to c square into 1 minus x square by a square minus y square by b square. So if you take its square root, it will be c time under root 1 minus x square by a square minus y square by b square. I hope you agree. Now if you look at its projection in xy plane, so suppose I call this as x-axis and this as y-axis. So in xy plane, this distance here will be how much? This distance on x-axis, the intercept will be a, on y-axis the intercept length will be b. So I have to take a vertical strip like this. So this will vary from y is equal to 0, and in this case this will become a part of ellipse. So the equation of this will be x square by a square plus y square by b square is equal to 1. So if I solve it, this will give me what? This will give me y square by b square is equal to 1 minus x square by a square. So if I simplify, I'm writing it like this, just I hope it is not confusing you. So y square can be considered as b square into 1 minus x square by a square. So the limit of y will be under root this. So under root this will give you what? b2 under root 1 minus x square by a square. And then finally the limit of x will be 0 to a. So this is how the limits will be written. I hope you have understood it, that I am taking a structure like this. First of all, for ellipsoid, I am able to visualize this in the first octant, and then I have to first find the volume, and then I am multiplying it by 8 for all the 8 different octant. So how do I get the volume in the first octant? Just take the limit of z first, then we have taken the limit of y, and then we have taken the limit of x. So I will write it dz dy dx. Don't get intimidated by this. I will just leave this because sometimes they directly ask you to evaluate the or put the appropriate limit. So if you evaluate it, the final answer will be 4 by 3 pi abc. Since this is a slightly complicated computation and the video will become extremely long, so I'm avoiding it, but in case if you're interested, you should certainly solve this, right? This will be also helpful in helping you master your integration skills. But you need to remember this because sometimes they directly ask the question that what is the volume. So if you remember, it is 4 by 3 pi AC, and I think you are smart enough to see the symmetry. If you talk about the sphere, it is 4 by 3 pi a cube. If we have the a sphere like x square plus y square plus z square is equal to a square, but it is distributed like a, b, and c, so a cube become abc. I hope you are smart enough to understand that. Okay, so compute this. Certainly some of you might be thinking that why should I put that much effort, but anyway, putting the effort or putting your own effort helps you to master the concept better. Now I am going to talk about change of variable, and first I am going to talk about rectangular to cylindrical coordinate system. In one of my video which was related to Jacobian, I have talked about this, but just for the sake of completeness in context of triple integral, I am again introducing it. So you see, this is a rectangular coordinate system. This axis is x-axis, this axis is y-axis, and this axis is z-axis. Okay, and we have a point in xyz plane, or which we call rectangular plane, rectangular system, and that point I am representing by r, theta, and z. So r, theta, and z is known as cylindrical coordinate system. So how this is related, you can clearly see that the z distance is same for both the cases. So if I write x, y and z, so z remains the same, there is no change in z. But what is this r here? So basically if you drop a perpendicular from the point pxyz in the xy plane, so this is the foot of the perpendicular, this point is the foot of the perpendicular. What is its coordinate? Its coordinate is x comma y comma 0. Now I join this foot of the perpendicular to origin and I am calling this length as r. So this is the length r, and this angle that I have taken, which the line joining the origin and the foot of the perpendicular of this point is making with x-axis. I repeat it to avoid the confusion. From the original point, that is xyz, I have dropped a perpendicular in xy plane. So if the original point is xyz, its foot of perpendicular will have the coordinate x comma y comma 0. Now this point is joined to origin, so the distance of this point and origin is r. Now this line, if I call this point P and if I call this point M, so the line OM is making an angle theta with x-axis. So if I take its projection in the direction of x, what will be x? X will be r cos theta. And if I take its projection in direction of y, y will be equal to r sin theta. I hope there is no doubt in that. Okay. Now this is the relation that you have to remember, that how x, y, z are related with r, theta and z. Some people also take it rho, theta and z, so that this distance they call it rho, but I think r will be more popular. And if you calculate the Jacobian of transformation, how will you calculate? I hope you remember that you fix x and then differentiate it with respect to r, and then x with respect to theta, and then x with respect to z, and then you take y with respect to r, y with respect to theta, and y with respect to z, and finally you fix z and you differentiate z with respect to r, z with respect to theta, and z with respect to z. We have done this computation. I would suggest you to do this and let me know that whether you are getting r or not. So this is the Jacobian of transformation. So whenever we will have a cylindrical coordinate system, and if we want to if the original problem is in rectangular and we want to change it into the cylindrical, then dx, dy and dz will be replaced by r, dr, d theta and dz, where r is the Jacobian of transformation. I think we have talked about change of variable in the previous video, and there I have told you that when you change the variables into new set of variable, you multiply it by the Jacobian of transformation. So the original set of variables are x, y, z, the new set of variables are r, theta and z, so you are multiplying it by the Jacobian of transformation, that is r. Okay. So you need to remember this. Sometimes they directly ask the question. I may take a problem or two. So let us before I take the problem, let us quickly talk about changing the rectangular system to a spherical polar coordinate system. And here there is a scope of confusion, because some people actually, and one more thing, I missed to talk about that. If I ask you that what is the limit of theta, so I hope you are clear that theta in this case will vary between 0 to 2 pi, because theta is the limit which the point which is the foot of the perpendicular of the point is making with x-axis. So this can be anywhere, this can be, so theta can vary from 0 to 2 pi. Now next thing is how to change rectangular to a spherical polar system. So in a spherical polar system, if I call this point as xyz, I drop the point from the point P, I drop a perpendicular in xy plane. So this point is P, I am calling this point M. Now what is the variables here? Like this is origin, right? O. So if you join this point O to P, you get a line, that OP line. The length of this line right now I am calling is R. And then this line will make some angle with z axis. So that angle I am calling as theta. And if I drop the point perpendicular from the point P in xy plane, that is the point M, and if I join O and M, this OM will make an angle phi with x-axis. So that I am calling as r, theta and phi. So what will be the relation between r, theta and phi? If you look at this x, y, z. So clearly if this length is r, So in direction of z, the projection will be what? The projection in direction of z will be r cos theta. So I write r cos theta, and its projection here in this direction. Now OZ and OM are two perpendicular line. So if I take its projection, this length, the OM dotted line, it will be r sine theta. Okay. Now I have to get the value of x, I have to take the projection of r sine theta in the direction of x, and that angle is phi. So x will be r sine theta and cos phi. And if I take the projection of r sine theta in the direction of y, it will be r sine theta and sine phi. So this is what the relation is. X is equal to r sine theta cos phi, y is equal to r sine theta sine phi, and z is equal to r cos theta. And I hope it is not very difficult to visualize that the theta can vary between 0 to pi. Can you visualize? Because theta, if I drop take the negative z axis, theta will be anywhere, but that line which will join the point to origin will make an angle, maximum angle will be pi. So theta will vary from 0 to pi, and phi will vary, this angle phi will vary from 0 to 2 pi. You just think about this. This is important. Don't remember, understand it. And here the Jacobian of transformation, if you calculate, is r square sine theta. So in this case, if I change dx, dy, dz into a spherical polar coordinate, it will be written as r square sine theta dr d theta and d phi. It is important. Sometimes they directly ask this question. Now what is the scope of confusion here? That some authors or some professors or teacher take this angle as phi and this angle as theta. So in that case, there will be a change. This z will become r cos phi. So how to just kind of sense it, that in the exam or problem they are writing z is equal to r cos theta, then you should sense that theta is the angle that the point joining the line joining the point and origin is making with z axis. So theta is the angle with z axis. Okay. Okay, fine. I hope I am not too fast, because I want to cover so many things, and this is something that are important for multiple choice based exams question, where they ask questions related to changing the Cartesian or rectangular to cylindrical or rectangular to spherical polar coordinates. I hope you have visualized. In case if you have not, just pause the video, think about this so that you understand it better. Okay, find by triple integral the volume of the sphere, that is x square plus y square plus z square is equal to a square. So we have seen the ellipsoid problem, but in this sphere problem I think you will not have much confusion, that here also I am going to take the region bounded in the first octant. So the region bounded in the first octant will look like this, the way I have drawn, and I missed this line. So can you visualize? Oh, bad picture. Pictures, there is a very famous saying that a picture is worth 1,000 words. I hope okay, I consider that. Just pardon me. I mean, I am not able to draw a good picture, but can we try once more? Yeah, let me try once more. Keep trying till the time you get slightly better. Practice makes the man perfect. Okay, better. So this is the I hope you understand. Do you like watermelon? If you cut watermelon, like if you just slice it vertically and then horizontally and then in between, then you will get one part which will be like octant, 8 pieces. Suppose I ask you that create 8 equal pieces of the watermelon. How will you cut it? So you will cut it along x-axis, and that will give you 2 hemispheres. Then you cut it along y-axis, that will give you kind of 4 octant, 4 pieces. And then if you slice it along z-axis, then you will get 1 octant watermelon. Visualize. I'm shooting the video in the winters. The watermelons, I don't know, is not available in the market, but still I hope you have visualized. So I will solve this problem, and I can solve this problem in Cartesian coordinate as, so if I write it in Cartesian coordinate, the volume will look like what? It will be 8 times. And the way we have done it, so I will take a solid kind of a structure like this, right? And this structure, if you look at this, it varies, starts at z is equal to 0, that is in xy plane. This is x-axis, this is y-axis, and this is z-axis, and it goes up to the sphere, that is under root a square minus x square minus y square, and then dz. And then you take its cross section in what? Cross section in xy plane. So this is the part of the circle, that is x square plus y square is equal to a square. So the limit of y will vary from 0 to under root a square minus x square. And then you take the limit of a, that will vary from limit of x, that will vary from 0 to a. I hope now you are mature enough to decide the limit, because deciding the limits is the very important thing. So 0 to a, and then I will write dz, dy, and dx. So if you evaluate it, you will get 4 by 3 pi a cube. This is the volume in one of the octants, and I am multiplying it by 8 to get the total volume. But suppose I want to change this into and basically this is just integration of dz, dy, dx. But if I write the volume using the spherical polar coordinate, so in that spherical polar coordinate, what we do, we will take a kind of a structure which will start at origin, right, and it will go up to the what? It will go up to the sphere, right? So how does it look like? Can we try to draw this? I mean, something like this, something like this. Can you see? I mean, starting at the corner and going up to the sphere. So if you look at this, this r will vary from what? R will vary from 0 to a. You agree to this? R will vary from 0 to a. Visualizing or not visualizing? R will vary from 0 to a. And how the theta and phi will vary? So if you look at this, this is the theta, right? Theta. So theta will vary from 0 to pi by 2. So the maximum, suppose this strip I am taking like this. So theta will be pi by 2. If the strip goes in this direction, then theta will be, in this case, the theta will be pi by 2, and in this case, it will be, 0. So first let me write the limit of theta. So theta varies from 0 to pi by 2, right? And how the phi will vary? So if you look at this angle with x-axis, let me call this as x-axis, because earlier I have taken in this side as x-axis. Where can I just show the picture? I was calling this as x-axis, so let me call this also as x and this as y. So in this direction the angle is phi. So how the phi will vary? Phi will vary from 0 to pi by 2. So phi will also vary from 0 to pi by 2, because I am taking just in the first octant. If I take all the 8 octants, then theta will vary from 0 to pi and phi will vary from 0 to pi, but I am calculating in one of the octants, right? And then r will vary from 0 to a, and we are multiplying it by 8, and then I will write the Jacobian of transformation, that is r square sine theta, and then I write dr, d theta, and d phi. The way, I mean, you could have written the limits here, r, theta, or phi in whatever order, because I have specified that limit of r is 0 to a, limit of phi is 0 to pi by 2, and limit of theta is 0 to pi by 2. This is the Jacobian of transformation. So first you can integrate it with respect to r or with respect to theta or phi, that does not matter, right? So I would suggest you to integrate this and confirm that here also the answer you will be getting is 4 by 3 pi a cube. Pause this and think about this very, very carefully, because how the limits have been decided, that I have taken a strip which is starting at origin and going up to the part of the sphere or surface of the sphere, so that r is varying from 0 to a, and this line which I have actually taken will make an angle theta with z axis. So the angle will be like this. So theta will vary from 0 to pi by 2, and this angle will vary from 0 to pi by 2. So r square sine theta, dr, d theta, and d phi. Okay. Can we quickly evaluate this problem. How much time I already have? Like 44 minutes. So let me do one last problem, and here I want to solve it using the what do you call cylindrical coordinate system. So because the way it looks like x square plus y square is less than or equal to a, and z varies from 0 to 1. So let me first draw the picture so that you can visualize it better. So let me call this as x-axis, this as y-axis, and this as z-axis. So I draw a cylinder like this. Oh, good picture. Fine. I hope you can visualize. So it is the plane z is equal to 0, and there is a plane which is parallel to xy plane, which is kind of cutting the cylinder. So this plane I will consider as z is equal to 1. And suppose this point, what is the coordinate of this point that I have? Uh, this point I suppose call xyz. I take any random point xyz just to visualize that. So if I take a point here and drop a perpendicular, right? So suppose I take a point here and drop a perpendicular over here. So something like this, right? So this is the point which perpendicular is. If I take a point here and drop a perpendicular, this is how it will look like. So if I join this length actually is known as r, and this angle is known as the angle what we have taken, so that we take the same variable. We have taken theta, so this angle I am going to take theta. Some people call phi, some people call rho. So that is why there is a scope of confusion. You be clear about, some people call r theta z, some people take it as rho phi z. So you need to be clear that which notation they are following. So if I have to cover this region, and one way to work the problem in xyz system, but I want to change it into r theta and z system. So can you decide what will be the limit? So here in change of variable, let me write it over here. So I take x is equal to r cos theta, y is equal to r sin theta, and z is equal to 1. Okay, so x square, so that will be like r square cos square theta, y square, that will be r square sin square theta, and z, so z is equal to z, not z is equal to 1. Here the limit of z will be 0 to 1, but the relation is x is equal to, I just want to show you again, x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. And r sin square theta, r cos square theta, r sin square theta, and z is equal to z, and I write dr, d theta and dz. So if I have to cover this cylinder and I want to cover this cylinder, so what will be the limit of z? It is very much clear that limit of z will vary from 0 to 1, because you have to cover this, so you take any vertical kind of solid structure, and limit of z will vary from 0 to 1. So limit of z is equal to 0 to z is equal to 1. I think I am tired, so I am making mistake here. So z is equal to 0 to z is equal to 1. And how the r will change? So now I have to move this strip to cover the cross section, that is x square plus y square is equal to 1. So how will you cover this region? So r will vary from 0 to 1, and this theta will vary from 0 to 2 pi. Can you visualize that how will you kind of cover this cylinder? So if you take a solid kind of structure which starts at z is equal to 0, goes up to z is equal to 1, and then you move it from 0 to r is equal to 0 to 1, and then change it 360 degrees, so you'll be able to kind of cover the whole cylinder. Okay, now let me integrate it. So theta limit is 0 to 2 pi, r limit is 0 to 1, and z limit is 0 to 1. So first of all I write r to the power 4 cos square theta sin square theta, and we have to integrate it with respect to z first. So I write z square by 2. Limit of integration is 0 to 1 and then dr d theta. So if I put this 1, z is equal to 1 and 0, so I will get 1 by 2. So I take it out of the integration. Theta varies from 0 to 2 pi. Now I have to integrate it with respect to r. So r to the power 4 will give me r to the power 5 by 5. Cos square theta sin square theta is constant in terms of with respect to r. So if I put the limit of r, that is 0 to 1, then d theta. So what I will get r to the power 1 to the power 5, 1 and minus 0. So I will get 1 by 10, 2 into 5. And then I have theta 0 to 2 pi cos square theta into sin square theta d theta. I hope there is no confusion till now. Is it clear? Okay. Did you notice that I made a mistake? And this is a very, very important mistake. Mistakes are not important. Means what I'm trying to say, this is a very, very kind of what you call a regular mistake people make. Can you visualize or can you point out what is the mistake? The mistake is that I have written x square y square z, no problem, but have I multiplied it by the Jacobian of transformation? The answer is no. So that mistake let me correct. This r I have to multiply. So if I multiply this r to the power 4 should be actually r to the power 5. So mistakes I am highlighting, it will be r to the power 5. So if it is r to the power 5, the integration will be r to the power 6 by 6. So let me use another ink, r to the power 6 by 6. And since it is r to the power 6 by 6, the thing that will come out here will be 1 by 12. 1 by 12 cos square theta sin square theta. I hope you are clear up to this. I have highlighted the mistakes that I have made using the red ink. Now how do you solve this kind of problem? So you can write 1 by 24. I just multiplied, and not 1 by 24, rather I have to multiply it by 4. So that I get do you know how to integrate? I write it 1 by 48, and you might be thinking why I have multiplied, because now it will become 4 times sin square theta cos square theta. So it will become 2 sin theta cos theta whole square d theta, and that is 1 by 48. Limit is 0 to 2 pi, and sin square 2 theta d theta. 2 sin theta cos theta is what? Sin 2 theta. So it will become 2 sin theta cos theta. So sin 2 theta square. Okay. So since we don't have the space, we have to move to the next page. So I have this expression which I have copied already. Sin square 2 theta d theta, limit is 0 to 2 pi. So how do you integrate this kind of integration? So 1 by 48 sin square 2 theta can be written as 1 minus cos 4 theta divided by 2 d theta. Now this will become 1 by 96, 48 into 2. Integration of 1 will give me theta. Integration of cos 4 theta will give me sin 4 theta by 4. Limit is 0 to 2 pi. So if I put the upper limit 1 by 96, upper limit is 2 pi, lower limit is 0. So 2 pi minus 0. And if I put theta is equal to 2 pi, it will become sin 8 pi, so that is 0, and sin 0, so that is also equal to 0. So that is what we get. So we get 2 pi by 96, so I will get pi by 48. Yes or no? So this is how you will be able to solve this problem. I hope you have understood. You can solve this using the rectangular coordinate also. In that case also the limit of z will remain 0 to 1, but then you have to take the limit of y, and then you have to take the limit of the x. But I believe changing it to the what you call cylindrical coordinate system has made the computation quite easier. So we have done a problem where I have changed the system into a spherical polar coordinate. Here I have changed it to the cylindrical coordinates. I introduced you that how the change of variable works, right? So this is all in this video. This was the last video in multiple integral series, and with this the units are completed. Next thing I am going to upload is MCQ videos. So in case if you are new to the channel, subscribe it and share with all your friends so they also get good quality video contents. Thanks for watching. Have a great day.